So this is the parkour game that I work on currently, and as you can see, I can literally walk around, the movement and then the roll, and as you can see, my camera follows my head. So when my head moves, my character moves with it, like this. Moves with the position and also with the rotation. And today I'll show you guys how to make it because under my recent video about making head camera, I said in the comments that if my comment get 10 likes, I'll make a tutorial on how to make it with rotation as well. So if you don't need a rotation and you just want your camera to follow position, like in for example, please donate, then go back to my first tutorial about head camera. But if you need the second option with the camera and head rotation, just stick along with this one. Alright, let's begin. So head to the Roblox studio and press F5 or the play button to start the game. As you can see, my character loads in, and then I can go to the player service, to my player, then player scripts, and I can see the player module here. Just copy that. Then stop the game, paste the module into the starter player scripts, go into the control module, oh, sorry, camera module, because we want to keep the control module, and just comment out the camera module object. This way, if we start the game, as we can see, the camera no longer updates, and that's great because we are going to make our own camera. Also, the second thing is that in the game, players can still use shift locked, and basically we want to get rid of it because it would just do nothing. So you can go to the starter player service and remove the mouse lock option here. Alright, now create a script, a local script inside the starter character scripts service, just a folder inside the starter player service, and maybe call it camera controller. Alright, so first things we need to do is to define our services. So local user input service equal game get service user input service. We will also need the run service and maybe player service. Okay, then we need game settings to determine the player sensitivity. Like this, and then we want to define our local player, then character, and wait for the character if it doesn't exist. Basically the player character added event, this event returns and provides the character, so after it waits for the character, it will be set to the character, so our character variable will always be character, or otherwise it will just wait for it and it will be character nonetheless. So then we need to define our current camera, which is just the workspace.current camera. Then what we need to do is kind of setting up the mouse behavior and the camera behavior. So we just do local player that camera mode equal camera mode that lock this person, and yeah, that wouldn't change anything because literally we are making our own custom camera, but those are the default states, and I'll recommend to stick along with them, and yeah, just use them. Mouse behavior equal mouse behavior dot lock center. All right, now we need to define the head because we are going to take the head rotation, then HRP, which is just the humanoid hood part, and of course our humanoid, and make the humanoid auto rotate property false because we are going to make our own auto rotate because we are making custom camera, right? And alright, now let's define the camera offset. So inside the humanoid there could be camera offset. So yeah, maybe just let's take it dynamically from the humanoid. So anyway, let's just define the last offset because we are going to lerp it so it's smooth. And also let's define the camera rotation. Don't change that variable, keep it 0 because it will be changed by the script. Now let's define the sensitivity, and it's equal to vector 2 that new, and for example 0.025 and 0.025, maybe like this. And camera clamp is equal to table, and the y-axis clamp would be number range and minus math.rad 80 degrees and math.rad 80 degrees like it's in the default. All right, so pretty much that's kind of everything and for the setup for now. And what we need to do is to create our update camera rotation function. So what we want to do is to make a function, let's call it update camera rotation, and let's define the mouse delta because we're going to use the mouse delta, and it's just from the user input service. Then the mouse sensitivity, and it's from user game settings. Mouse sensitivity. Alright, and now let's set the camera root to vector 2 that's new. And for the x-axis, we are not going to do any kind of clamping because you can just rotate around and there is no any kind of limit for the x-axis, so let's just not clamp it and just set it to the same value but subtract the delta times sensitivity. So it will be mouse delta.x times mouse sensitivity times sensitivity multiplier for x-axis. Yeah, and pretty much the same for the y-axis, but we need to clamp it. So you can't just, make your camera 360 degrees, or if you want, you can make it like this, but we are not going to. So camera rod that y minus mouse delta that y times mouse sensitivity that no, times sensitivity multiplier that y, and also we are going to make here the clamping. So we are going to say here kind of camera clamp that y that's minimum and camera clamp that y that max. So that max, yeah, and that's pretty much how we clamp it. But there's an error. Okay, expected to close. Where is it? Okay, here's supposed to be a comma, and now it works perfectly. Okay, so we got the update camera rotation function. What we need now to do is to create a camera updater, kind of. So let's just bind to the render step. Let's call it camera update. Let's use the render priority of the camera. So camera.value, and now here's the function. The first argument is just delta time. So let's just call it dt, and it is a type of number. So what we need to firstly do is to check if the head or HRP doesn't exist, and if it doesn't, just return end, and we don't want to continue. Then we want to update camera rotation, so we just call this function, and we want to define the head cframe. So let's say local head cframe equal head.cframe, local HRP cframe equal HRP.cframe. Yeah, and now local offset equal to last offset lerp camera. Oh no, we are just going to take it from the humanoid, so we also need to check if the humanoid exists. So if not humanoid, then return anyway. And here we are going to say camera offset. And yeah, and just let's do the delta time times 20, I guess. Yeah, something like this. Or maybe just maybe 10. That would be better. And last offset equal the current offset. Alright. Now what we want to do is to multiply or offset by the C-frame. So what we kind of need to do is just offset equal offset.x times the right vector of the HRP C-frame plus HRP C-frame, or it's offset.y times HRP C-frame dot up vector plus offset.z times HRP C-frame dot look vector. So that's pretty much how we make our camera offset be kind of local. So we just multiply it by the look, right, and up vector of our HRP C-frame. Okay, so now we want to define the rotation. So let's say local HRP. It's actually not that easy because let's just set it to the C-frame. I'll show you why. Because if we set it to like to rotation, yeah, a C-frame to rotation, as you can see, it returns the y, x, z. So the first parameter would be y, second would be x, and the last would be z. It is kind of switched between these two. And here we are going to say local row. Yeah, there will be just the row C-frame, and it will be equal to head C-frame, because we are going to use the head rotation, plus offset here, and we're going to multiply it by negative the HRP C-frame. So I mean the rotation of the HRP. So we're going to take the camera, kind of the head C-frame, right? So like the head looks forward or some kind of this, and we are going to take out from this the humanoid root part C-frame. Yeah, not the real C-frame, but just the rotation. So we're going to take, we're going to have head C-frame and subtract the humanoid root part rotation from it. So what we are going to get out of it is just the C-frame with the offset from the base. So we are not going to, you know, rotate our camera by whole step. I mean, kind of whole, whole kind of start. Like, yeah, we are not going to take into account the whole rotation of the camera. We're just going to get the offset, like how is it different from the default rotation, right? So yeah, that's pretty much how we make it. So we are going to just subtract it. So minus hrp.y and minus hrp.x and minus hrp.z. So we're just going to subtract the HRP rotation from our head C-frame plus offset. Yeah, and that's pretty much it. Now let's define the rotation, and it's equal to C-frame.angles 0 camera rotation dot x 0, which is just the the roll. And now let's define the pitch. Is it the roll? No, it's not a roll. That's the yaw. Yeah, this is yaw. Okay, this is yaw. Roll would be here. So here's roll, here's yaw, and this is the pitch. And let's set the pitch. Camera rot dot y 0 0. And remember that the order that you multiply it in matters, because we're not going to create a new C-frame which would be looking like this without this, of course. This is wrong, because what would you do is just taking out new C-frame C-frame angles and make kind of diagonal line. right? And if you make it like this, you firstly just make a straight line on the yaw axis, and then you just add a pitch. And this way, you're not going to get kind of the diagonal rotation. We are just going to multiply it one per time. One rotation at a time. So um, yeah, that's kind of it, and that's why the order matters. And yeah, just keep it like this. And here, just you're just going to set the camera C frame to row times rotation. Yeah, and that's pretty much it for the camera rotation. Let's hit the F5 and test it. Oh, it doesn't work. Output shows no errors. Let's see why. So pretty much we're waiting for the head, humanoid root part, the humanoids. Here is the camera update. Alright, but it doesn't work, and let's see why. I mean, we can kind of print something here. Print A, or like this, print I, and let's see if it prints. It doesn't print. And why it doesn't print is kind of strange. Let's say we are going to print here. Print hello world, and in character has loaded. Let's say now if it works. Okay, it says hello world, but it doesn't say the character loaded. So it could be waiting for the character for infinite amount of time. But why? Let's see. Player service, okay, local player is equal to players.local player, character is equal to local player.character, or it should be not and, but or. Yeah, that is an issue. Let's see now. There we go. It says hey, but it doesn't say hi. And why it doesn't say hi? It could be because it is returning if the head doesn't exist, but it should be existing, and or not HRP or humanoid. Okay, so here's another error. So if if a humanoid exists, we just return. Which we are going to do if the humanoid doesn't exist, then we return. Not if it exists. And now, as you can see, everything works. But you can still see your whole body, and that's not good. And also, if you rotate around, it doesn't work. And even if you enable back the auto rotate variable, it wouldn't work anyway because we disabled whole camera module. So let's fix it. Firstly, remove all the prints from our code. And yeah, let's bind new function to render step event for the character rotation. So let's call it character rotation update, and let's set it to render priority of our character, obviously the value, and here's our function. The parameter is just the delta time, and we are going to say if the HRP doesn't exist, then we return. Let's define the humanoid root part C-frame, and it's equal to HRP.C-frame, and here we're going to say HRP.C-frame, and it's equal to C-frame.new, HRP C-frame.position. So it's a row position times C-frame from orientation, and now we are going to use the yaw axis. So camera rot.x, and yeah, that's pretty much it. Let's see if it works. Yeah, it does in fact work indeed. That's great. And now what we can do is we can kind of determine if it should be rotating or not. So we are going to say if the humanoid that auto rotate, then return end, but we are going to do if not humanoid that auto rotate. So if the humanoid that auto rotate variable is set to false, we are not going to rotate. And let's see if it works. Okay, we are not rotating. And now if we set the variable to true, we are rotating. So it works great. Okay, let's set it back to true then, or just remove it. All right, there we go. But there's one issue still, that we can see our entire body. So what we can do is we can define which part we want to see. So let's create a new table and call it visible parts. And in this table, let's put the torso, left arm, left leg, right arm, and right leg. Remember that if you are using R15 characters, you should also include R15 body parts, body part names here. So for example, instead of torso, you would just say upper torso, and of course the lower torso, and so on, you know. So yeah, but yeah, I'm just doing R6 for now, so let's keep it like this. And here we're going to say run service as pre-render, so every time the new frame renders on our screen, obviously there is a delta time, and we're going to look through all the parts inside the character. In character get the scandance, so yeah, we're going to look through all of the scandance and see if they have the okay. So there is one issue with that. So there could be more than one type of parts that has transparency property. For example, decals like our face also could have the transparency property. So what we can do instead of checking the type of our instance, we're just going to make a pickle that will just you know, catch the error and just not show it in our output. So we are going to say here part the transparency, local transparency modifier is equal to table.find visible parts, part.name, and 0 or 1. So if it finds in the visible parts the part name, it's just going to set it to 0 or otherwise to 1. So yeah, pretty much it. If it finds if it finds the torso, then the torso is visible. If it's not a torso and it's not something in the table, it's not going to be visible. And let's see if it works. It actually works indeed. And also, what we can do extra is add an offset to our humanoid. Yeah, the camera offset. So let's say the Z plus 1. So we have our camera in front of our character. And yeah, and now if we dance, our head also follows the rotation. Yeah, our camera also follows the rotation of the head. And that's great. Okay, one more thing. So as you can see, my cursor is moving around and I don't want it. So what we can do is we can make the mouse behavior update inside or renders or inside our pre-render method. So we just make sure that it's locked in the center no matter what. And let's see now. All right, it is locked in the center indeed and works great. And that's pretty much it. Now if you roll, it should be working. So let's test it out. In my case, I'll just define the alright, I just make a quick pseudocode for that. So let's say alright, let me paste in the animation ID from my group, return float 4. Let's see where's the roll. It's the volt, slide, jump, fall, idle, running. But where's the roll? Vaulting, volt, test, wave. can't find the role. Is it here? Oh yeah, here is role running. Let's just copy the ID, paste it here. Let's make sure it's using the right URL, and it is. So yeah, and now we are going to say that humanoid.r.animator load animation animation, and now we are going to play it, and that's pretty much it. Let's test it out if it works. Now if I press E, my character rolls, and yeah, and my camera rolls with my character. And that's pretty much it for the tutorial.